For this problem, we have the series of n equals 3 to infinity of -1 to the n plus 1 times n plus 1 over n cubed plus 3. My initial thought is to do the alternating series test. And that means you have a b sub n plus 1. And when I look at it in my head, the b sub n and the b sub n plus 1 will both have an n cubed on the bottom. And then that's going to be a little bit harder to figure out which one will be bigger or smaller, really. And we may not even be able to figure it out. So that's one reason why I'm thinking more of a comparison test. On top of that, we're wanting to know if it's absolutely or conditionally convergent or divergent. And we know that if we remove the alternating part and it converges, then it's absolutely convergent. And if it diverges, then it is conditionally convergent. So, when doing that, we're going to remove the alternating part. So we have an n plus 1 over n cubed plus 3. Well, first, now we know that if we take the absolute value, this will never, we have a positive value here. So this is always going to be positive. It's never going to switch or anything like that. When I think what I'm going to compare to, I take away these constants and I have an n over n cubed. Well, really that's a 1 over n squared. So we can compare it with that. Now when we compare that, n cubed gets a lot bigger, a lot faster than an n squared, and even just an n. So if this is getting bigger, bigger, the whole thing is getting smaller, so we know that that one's going to be smaller. And we have, this is a sub n and this is b sub n. Now that's the first thing we have to check when we do a comparison test. And actually we have to think about it as a sum there, but that's what I was talking about when we know that this starts at 3, so the n cubed can never be negative. We took that out. Moving on. Now we want to see if the sum that we're comparing it to is convergent or divergent. Well, we have to think back. We learned the p series, which is the sum of 1 over n to the p. It converges if p is greater than 1. It diverges if p is less than or equal to 1. Well, here p equals 2, which is greater than 1, obviously. So b sub n converges. And the comparison test says if b sub n is convergent, then a sub n, the sum of a sub n is convergent too. So that's how we know that this is convergent. And like I said before, if you remove the alternating part and this converges, then it is absolutely convergent.